Welcome to day 27 of our low-level design course. Today we are going to explore the low-level design of a book-my-show-like ticket booking system. In this session, we will break down the system into its fundamental components, design core modules, address key challenges, and implement best practices to ensure that the system is both robust and scalable. By the end of this session, you will have a solid understanding of how to design a real-world ticket booking platform similar to BookMyShow, complete with all its intricate features from seat booking to payment and notification handling. Let's start with an overview of the BookMyShow-like system. The main function of this system is to allow customers to browse and search for movies or events, select the theater, choose a showtime, and then book tickets. The customer also has the ability to cancel bookings if needed. A user can search for movies based on several filters such as movie name, showtime, and location. Once they selected their desired show, they can choose seats, proceed with payment, and receive confirmation through email or SMS. Key actors involved in the system include the customer who interacts with the system to search and book tickets, the admin who manages the available shows, movies, and seats, the theater owner who updates showtimes, seat availability, and may interact with the admin for system changes. The high-level features of this system include searching for movies and events, selecting a theater and show type, booking tickets and making payments, sending notification, post-booking to confirm the transaction and ticket details. Before we dive into designing, it's important to understand the requirements that drive the system's functionality. This can be categorized into functional and non-functional requirements. First, let's take a look at the functional requirements. The system must support browsing and searching of movies and events based on various filters such as genre, language, showtime, and location. It should allow users to lock and select seats, ensuring that no double booking can occur. Integration with payment gateways is essential for processing payments and confirming the bookings once payment is completed. Notifications need to be sent after booking confirmation, payment success, or cancellation. For the non-functional requirements, the system must be designed to handle high concurrency. This means that it should be able to handle thousands of users making bookings at the same time without crashing. Consistency is vital to prevent issues like double bookings. We need to ensure that the system behaves reliably even when many users are interacting with it simultaneously. Performance is key. We want fast responses when searching for movies or selecting seats so users don't experience delays while interacting with the system. By addressing these requirements early on, we can build a solid foundation for our system's design. Now let's focus on entity modeling. Entity modeling is an important step in low-level design because it defines the core objects in our system and the relationships between them. For this ticket booking system, we have several core entities. User. This class will store details of the customer, including name, email, and past bookings. Movie. This entity contains details about the movie, such as the title, genre, duration, and associated showtimes. Theater. This represents a cinema theater and includes information about the location, available shows, and seat arrangements. Show represents a movie being shown at a specific time and at a particular theater. Seat represents an individual seat in a theater. It can have various statuses like available, locked, or booked. Booking stores information related to a customer's booking, such as the movie, show, selected seats, and payment status. Payment handles payment related information, including payment methods and transaction statuses. Notification handles the delivery of booking and cancellation confirmations for the users. These entities are interconnected. For example, a user can make multiple bookings. Each booking involves one or more seats, and each seat is linked to a show in a specific theater. By modeling these relationships clearly, we ensure that our system is easy to maintain and extend in the future. As we design the system, we face a number of core challenges that need careful consideration. Seat locking. This is one of the most critical aspects of that design. When a user selects a seat, we need to temporarily lock it so that no one else can book that seat during the booking process. If the booking fails, the seat must be unlocked. Proper locking mechanisms are crucial to prevent double bookings and ensure data integrity. Concurrency handling. Since multiple users can look to book seats at the same time, we need to handle concurrency effectively. This might involve using synchronized methods or locking mechanisms like optimistic and pessimistic locking to ensure that once a seat is locked, no other user can select that same seat. Payment integration. Payment is another area where the design needs to be robust. We need to integrate with payment gateways, but importantly, we must ensure that a booking is only confirmed once the payment is processed successfully. This means the booking entity should only be marked as confirmed when the payment is successful. Notifications. After a booking is confirmed, the user should receive notifications whether through email or SMS confirming the details of their ticket. Similarly, in cases of cancellations or payment failures, notifications should be sent to the user in a real time. Let's take a deeper look at the class design for this system. We will break down some key classes and their responsibilities. User. This class stores customer information such as their name, email, and a list of previous bookings. It also allows the user to manage their profile and view past bookings. Booking. The booking class encapsulates details about the ticket purchase such as the selected movie, show, seats, and payment details. This class also tracks the status of the booking, whether it's pending, confirmed, or cancelled. Seat Manager. The Seat Manager is a critical component responsible for managing seat availability and ensuring that seats are locked or unlocked during the booking process. It communicates with the theater's seating arrangement and updates the statuses in real time. These core classes serve as the foundation of our design, ensuring that our system works efficiently while handling all the complex interactions involved in a booking ticket. Next, let's look at the sequence diagram for the booking process. This diagram outlines the step-by-step interactions between the user and the system. The user begins by searching for a movie. Once the movie is selected, the system displays available showtimes. The user then logs the seats they want to book. These seats are temporarily unavailable to other users while the booking is in progress. The user proceeds with the payment process, choosing a payment method and completing the transaction. Once payment is confirmed, the system marks the booking as confirmed and sends out the confirmation notification via email or SMS to the user. This sequence ensures that all actions are properly synchronized and the system reacts in real time to the user's action. Design patterns help us structure our code and solve common problems efficiently. In this system, we are leveraging several key design methods. Singleton pattern. We use the singleton pattern for managing the seat manager class. There should only be one instance of seat manager per show to handle seat availability across all users. Factory pattern. The factory pattern is applied when creating different types of seats, VIP, regular. The seat creation logic is centralized in a factory class, which returns an appropriate seat object based on the parameters passed. Observer pattern. This is used for notifications. Once a booking is completed, the system notifies the user through different channels such as email or SMS. The observer pattern allows for easy addition of new notification channels without affecting the rest of the system. Strategy pattern. For payment processing, we apply the strategy pattern to handle different types of payment methods. Example, credit card, debit card, or UPI. Each payment method is encapsulated in a strategy class that the payment processor class can switch between depending on the user's choice. For those interested in advanced design topics, let's briefly touch on a few concepts. Microservices architecture. The system could be split into separate microservices for each function: movie management, booking management, and payment processing. This approach would improve scalability and allow each service to be deployed and maintained independently. Caching. We can implement caching for popular movies and shows to improve the response time when searching for movies. This will ensure that the system can handle high traffic while keeping the user experience fast and responsive. Database modeling. We also need to think about database choices. Depending on our needs for consistency and scalability, we might consider a NoSQL database for high availability and fast reads, or a SQL database if we need strong consistency for transactions like payments. For your assignment, we are going to focus on the cancellation and refund process. You will need to design an end-to-end flow for handling cancellations, issuing refunds, and updating the seat availability. You should also design the class and sequence diagrams for this feature, taking into account concurrency issues such as ensuring that once a user cancels a booking, the seats are released for other users to select. To wrap up, here's a quick summary of what we have covered today. We started by defining the problem and understanding the core requirements. We designed the entities and their relationships, ensuring that the system is well structured. We discussed the core design challenges such as seat locking, concurrency handling, and payment integration. Finally, we explored the design patterns used in this system and how they help in making the system more maintainable and scalable. Before we finish, make sure you have completed the checklist. Problem understanding. Do you fully understand the system requirements, entity and class modeling? Have you modeled your entities and designed your core classes? Concurrency handling. How are you handling concurrent seat bookings? Payment flow. Is your payment process well integrated and reliable? Design patterns. Are you using appropriate design patterns for extensibility and maintainability? Thank you for your time today, and I look forward to seeing your assignment submissions.